right, textbooks open to page 320 as we get started with our last review before the exam tomorrow. So quarter exam over sections 4.1 to 5.4, all things graphing, all things functions, all things systems, kind of the three major categories if we had to break it down that way. One of the things we were working on at the end of the hour yesterday and didn't have time to finish, so I gave it to you as homework, was 17 to 22, finding domain and range of various functions. And there are 5 limitations on functions, remember. Constant functions, absolute value functions, quadratic functions, radical functions, and rational functions. So it's not one of those 5. You know, there's really no limit on the domain or range as far as we're concerned. So number 17, what did you get for the domain, Kendall? All real numbers. There's no limits on that. It's not a rational function, so therefore the range was also all real numbers, right. Now number 18, we have an absolute value function. What is the domain, Maddie? You can take the absolute value of anything, right? That's not a problem. But absolute value only gives you what kind of numbers, class? Positives. And then we're going to add 16 to all those positives. What's the range on number 18? Genesis? Michael, help?
16 to infinity.
Good. Initially 0 to infinity, right? If you're picturing the number line, Genesis, remember 0 is the dividing line between positive and negative, so everything positive is 0 to infinity. But then when we add 16, it just shifts the whole thing down and starts at 16 up to infinity for our range. Number 19, what is the domain going to be? Let's go back to Genesis on the quadratic function. All real numbers, you can plug in anything, you can square anything, but because when you square, it spits out a positive, you get that parabola shape, and we're going to go from the vertex up for our range. So what do we get for the range here, Audrey?
Negative 10, infinity.
Negative 10 up to infinity. Good. We're going to start at the y value, or f of x value for the vertex, and go up to infinity. Of course, if it had a negative in front of the x squared, we would have gone negative infinity up to that negative 10. But it didn't say that. Number 20, they give you a little bit of a tricky-ish one. What is the domain going to be here, Brandon? 18 to infinity. You have to have a positive radicand, meaning 0 to infinity in the radicand. But plugging in anything smaller than an 18 gives you a negative, so we have to have at least an 18 or bigger in the radical, or as our x value. So domain 18 to infinity. That particular radical can only spit out what kind of numbers? Abby? Negative. Normally, we would think it spits out positive because there's an understood positive. This one has a negative, so it only spits out negatives. But we end up adding 3 to all of our negatives, so we get?
Negative infinity to 3.
Good. Negative infinity to 3. Again, your negatives would be from 0 to negative infinity, though we read it from left to right, negative infinity up to 3, up to 0. Then we add 3, and we just shift the thing down, negative infinity up to 3. Great job. Number 21, we have the rational function, and the key with the rational function, class, is denominator cannot be 0. That's what limits your domain. So on number 21, our domain can be anything, Kendall, except negative 5. I'm going to skip to 22. On 22, Maddie, our domain can be anything except negative 4, which means we will have what at negative 5 on number 21 and what at negative 4 on number 22. Anyone? If we were to graph, what would be in our graph? Because our domain, watch, look at this way. Our domain is anything, negative infinity to positive infinity, except right there at negative 5. You don't have any x values. So what goes right there at negative 5, class? How do we get a gap in the domain? The asymptote, right? There would be an asymptote at negative 5. Or in number 22, there would be an asymptote at negative 4. For the range, what is that limitation again, Maddie? Well, no, I'm not asking for the answer. I'm just saying in general for a rational function, if we have same powers of x in the top and bottom, what is it that determines the limit on the range? Because you can get out anything except the ratio of the leading coefficients. So on number 21, Maddie, now I'm looking for the answer. The range is everything except 1. And on number 22, Genesis, the range is everything except On number 22, we're looking for the ratio of the leading coefficients, not the trailing constants, the leading coefficients. 16 to 1 or 16, right? Y can be, or f of x, rather, can be anything but 16. So again, on your graph, you're going to have negative infinity up to positive infinity, except at 1. There's not a value there. Well, that means you'd have a horizontal asymptote, or at 16, you'd have that horizontal asymptote. Anyone perfect on 17 to 22? All right. Those who were not, do we understand them better now, having tried them? Question?
No.
Oh, that was you understand better. Okay, the look on the face made me think you maybe had a question. Are there any questions? All right, well, let's go ahead now. 23 and 24, determine, is that thing a function or is it not a function? Take just a moment to do both of those. Shouldn't take you more than a few seconds, honestly. We mentioned it yesterday, didn't practice it yesterday. How do we determine if an equation is a function? All right, what makes a function is if you plug in an x, you get out one y value, or one f of x value, correct? Well, here it uses y instead of f of x. So solve for y. Get y by itself and see what happens. On number 23, if we get y by itself, what does our equation become, Michael?
It becomes negative 3x plus 12 divided by 7.
Negative 3x plus 12 all over 7, right? Or if you want to do the slope-intercept form thing, right? Negative 3/7 x plus 12/7, whatever. Well, if I plug in a single x, I'm only going to get out one y. So that would be a function. Also, it's linear, right? And it's not a straight up and down line. Right? This wouldn't be a function, but it's a line. Lines are going to be functions, one for one. But number 24, you try to get y by itself. Obviously, we move the x squared over class, and then what do we have to do? Take the square root. When we take the square root, what do we have to put? Positive, negative. And so you plug in an x value, you do 16 minus whatever you got squared, take the square roots, that gives you two y values. That positive, negative tells you, class, not a function. Also, if you remember, what shape would you get from x squared plus y squared equals 16? A circle. Remember from the graphs we looked at the other day. And a circle doesn't pass the vertical line test. A line passes the vertical line test. A circle fails vertical line test. That's another way you kind of cheat and tell by looking at them. Oh, based on what shapes those would be. If you memorized that, you didn't have to. All right, questions on those. Let's drop down now to 25 and 26. They give you f of x, they give you g of x. They want you to find fg of x and f over g of x on 25 and 26. Call this combination of functions, where you're putting a couple functions together through either addition, subtraction, multiplication, or division. All right, remember when it says fg of x, it means multiply the f function times the g function. They're both f of x and g of x, so multiply them. So we take the f function and the g function in class. To multiply, we'd have to double distribute. There we go, double distribute. We'd have to double distribute. And what do we end up getting for our answer when we double distribute here? Maddie, did you get number 25? Good. X cubed, positive 4x squared, negative 3x, negative 18. How many had that for 25? Questions on 25?
I took f of g of x.
Oh, okay. Yeah, careful. Not f of g of x, but fg of x. So in number 26, when it says f over g of x, that means divide the f function by the g function. And the quickest way to divide would actually be to do what, anyone?
Synthetic.
You could do synthetic division. There's actually something quicker.
Okay.
Factor and cancel. You could factor x negative 2, x positive 3, cancel the x positive 3's, and just get x negative 2. But x can't be negative 3. And that's what we would get for our answer there on number 26. Question, how many had that for 26? X negative 2, where x cannot be negative 3. All right, questions on number 26? Questions? All right, I want you to do just the first part of 27 and 28. They give us new functions now. They give us f of x is x squared negative 10x negative 24, and g of x is 3x plus 4. I want you just to find f plus g of x, and then f minus g of x. Don't evaluate yet. Just do the first part of these. When it says f plus g of x, remember it literally means take f of x and add g of x. And what do we end up getting for our answer here, Audrey?
X squared negative 7x negative 20.
Good. X squared negative 7x negative 20. How many had that? Questions? And then for f minus g of x, it means take the f function, subtract, or class, add the inverse of the g function. So here, the only trick was remembering to add the inverse of both the 3x and the 4. What do we get for our answer there, Brandon?
X squared negative 13x negative 24.
Negative who?
And 28.
There we go, negative 28. X squared negative 13x negative 28. How many had that for number 28? I think that's what that was. Yes. All right, now they want you, now that we have our answer, in fact, let me go and write this up here. Now that we have f plus g of x, since we found it anyway, to find f plus g of negative 1 is easy. I just plug in a negative 1. Or f plus g of 2. Or f plus g of 3. At your seats, find these values, and then we'll do the same thing over here for f minus g of negative 1, of 2, and of 3. And since we already did the combination, makes it a little easier to evaluate the combined function. right, let's take a look at these for sake of time. F plus g of -1. What do we get for our answer here? Abby?
A negative 12.
A negative 12 when we plug it in to the already combined function. You would get the same thing, by the way, if you found f of -1, got your answer, and then found g of -1, got that answer, and added them. But since we've already done this, why would we go through that? Does that make sense? All right, what do we get for f plus g of 2, Kendall?
Negative 30.
Negative 30 is correct. What about f plus g of 3, Michael?
Negative 32.
Negative 32. How many in all three of these correct? Okay, questions on any one of these? Do we need to see any of those worked out? You say, how did you get that? All right, similar thing over here with the f minus g of -1, 2, and 3. What did you get for f minus 1, or f minus g of -1? Audrey?
Negative 15.
Genesis?
Negative 14.
Negative 14, so off just a bit there. Back to Audrey for redemption on f minus g of 2.
Negative 50.
Negative 50 is correct, and then f minus g of 3. Maddie? Negative 58 is correct. How many went 3 for 3 on those? Any questions on those? What if I wanted to find fg of, I don't know, 6? Well, there's two ways to do it. The slow way is to take the time to actually multiply fg of x, like we did earlier, and then plug the 6 in. What's the faster way? Yeah, find f of 6. Well, at your seats, go and find f of 6. Go and find f of 6. And what do we get?
Negative 48.
Negative 48. And then find g of 6. What do we get? 22. And then on your calculator, do what with them? Multiply them. fg of 6, you multiply, get an obscenely small negative. Negative 1086. 56? That sounds good. Questions on that? Again, why would you take the time to double distribute and then plug in a 6, right? Just do it that way. The only reason we plugged it in here this time was we'd already found it. Why not? We could also find, for instance, f of g of x. And I believe this is what Abby did earlier at your seats. Go and do what Abby did. This doesn't mean fog, it's f of g. It's just, it was supposed to be smaller. Whatever. F of g of x. Remember, there's two other ways you could write it. You could write it f of g of x, like this, or since g of x is x plus 3, you could say f of x plus 3. Ultimately, this is what you're doing. You're replacing the x with the x plus 3. You're replacing this x with x plus 3 to get x plus 3 squared plus x plus 3 minus 6. When we square the x plus 3, class, we get? There we go, the perfect squared trinomials. We square the first square, the last multiplying double. We'll add the x plus 3 and put that negative 6 there to get what for our answer, Abby?
X squared plus 7x plus 9. Wait, a second.
6?
Yeah.
Plus 6. And there we go. How many had f of g of x is x squared plus 7x plus 6? Now, technically, with these composed functions, we'd have to say, well, what's the domain here, class? All real numbers. What about here? What does it appear the domain is here? And you put all three together and still be all real numbers. Good news, I'm not going to do that to you on the exam. All right? But I will have you solve, for instance, numeric values. The strategy to numeric values is don't take the time to find f of g of x or g of f of x first. So, for instance, if I said I want g of f of 2, don't find g of f of x. Just evaluate first, class, f of 2. What is f of 2 at your seats? 0. 4 plus 2 minus 6 is 0. And this becomes then g of 0 because f of 2 is 0 and g of 0, class, is 3. Questions on that? At your seats, I want you to find f of g of 2 and g of f of negative 2. G of f of g of 2 and g of f of negative 2. What do we end up with for f of g of 2, Genesis? What should we have done?
Put the g of x in for x.
No. That's if we're plugging. We don't want to do it the hard way. You could do it that way. That's really, really hard. We want the easy way. Class, what do we start with? G of 2. Start with g of 2. Genesis, you can do this in your head. What is g of 2? 3 times 2.
6.
Plus the 4.
10.
So this becomes f of 10. Now we plug in 10s in the f function. And what do we end up with, class? Negative 24, because we get 100 minus 24 is negative 24. Does that make sense now? I already got the negative 24, by the way. Question? You did the backwards. You did f of g. Right, remember, start with the second one, the one that's closest to it. So here, for instance, on the next one, Audrey, we'd have to start with f of negative 2. So we plug in the negative 2's in these places here. And what is f of negative 2? Help, Maddie? I got 0 as well. We square a negative 2, that's 4. Negative 10 times the negative 2 is positive 20 minus 24. I've got a 0. So this becomes g of 0, because that's what f of negative 2 is. And then g of 0 gives us 4. Should have been our answer. How many had 4 for g of f of negative 2? Let me give you a couple more. Let's say we've got f of x is 2x minus 7, g of x is x squared plus 3, and let's go to the next one. H of x is 6 minus x, and let's suppose I want f of h of g of, let's do 1. Add your seats. Hold it up, what'd you get? You. That was really quick. I was like doing it in my head and then I turned around to see if anyone else had it. You were like right behind me, dude. That was impressive. And the answer, class, is? Negative 3. How many had the negative 3? Okay, so we start by finding, class?
G of 1.
G of 1. What is G of 1? 4. So then we're finding f of h of 4. Well, what's h of 4, class? 2. So now we're finding f of 2. And what's f of 2? Negative 3. Does that make sense? Not plugging the functions themselves in, as that takes too long, but just evaluating. Anyone want one more like this? Then we need another one. Questions? All right. Let's drop down to 31 and 32, then working with some quadratic functions. Of course, we know a quadratic function, class, will be graphed as a Parabola, there we go. Hand motions help. And of course, quadratic equations could be graphed a lot of different ways, we noticed. But to be a quadratic function, it's going to be a parabola. And we said that our base parabola has the vertex class at 0, 0, right? So our normal, ordinary parabola, vertex starts at 0, 0 class, and then we go over 1, up 1, over 1, up 3, over 1, up 5, and so on and so forth, right? But there's a lot of things we could do to this base parabola, f of x equals x squared. We could flip it over. We could shift it forward or backward. We could shift it up or down. We could even either stretch it or compress it based on the way the equation turns out. They want to know on 31 and 32 what weirdness has been done to the base parabola. 31 and 32, at your seats. List the changes that have been made. You can use shorthands and symbols as needed, as long as I clearly know what you mean. All right, if it's at the end, class, what is that? That's our vertical shift, up and down. If it's a positive, negative at the very beginning, that tells us whether or not we flip or reflect, as it says. The A here tells us our stretch or compression. When would it be a compression?
If it's a fraction.
Technically, if it's a proper fraction, so something less than 1, but yes, practically speaking. And then what about the minus plus h? And notice that's if it's grouped with the x. That's our horizontal shift. Now the key to the horizontal shift is it's backwards. Negative shifts forward, positive shifts backwards. So we have to think opposite. So on number 31, there's only 2 changes to the basic parabola. What are they, Kendall?
Forward 1 and up 3.
Good. Forward 1, up 3. On 32, there are 4 changes. And let's see if Audrey can go 4 for 4.
You flip it, you stretch it 5. You go left 6 and down 11.
Good. Flip it, stretch it 5, backward 6, down 11. And aren't you glad you don't actually have to graph that one? Questions on that? Now keep in mind, how many got both of those correct? You're good to go? All right. Now keep in mind, normally when we look at a quadratic function, it's going to be in the form ax squared plus bx plus c. That's our general form. That's what it's supposed to look like. So what we've got to be able to do, remember, is get it into this form. So remember I said what we're going to have to do is look at the first 2 terms, class, and factor out the a. That's going to leave us with an x squared by itself plus something x, and we're going to have a little gap. We're going to leave the c on the outside looking in. He doesn't fit in. And then, class, we're going to have to complete the square. 2 things to complete the square, half and square. So if we half and square, that gives us a b halves squared, if you will. Well, whatever value goes here, we're also going to have to subtract here, but account for the a. It might not really be a b halves squared. It might be, well, multiplied by the a. So whenever you add here, subtract here, accounting for the a. I want you at your seats to do numbers 33 and 34. Don't graph them yet. Just convert them to the standard form. 33 and 34, just convert them to the standard graphing form. let's go ahead and take a look at these together. On the first one, again, you're going to look just at the first two terms and see if there's anything you need to pull out. Anything that's in front of the x squared has to come out. But class, not there, so you don't need to worry about it. We'll just group those first two terms and leave a gap. The 14 class we put outside the parentheses. What goes in that gap that we left? Audrey?
16.
How do we get 16 class? Two things. Half and square. So we half the 8 to get 4 squared to get 16. Well, that's what goes in the gap. Is it really a 16 class? Yeah, it really is. There's nothing out here that would multiply to make it anything different. So if we put a plus 16 inside class, we have to compensate by putting a negative 16 outside. Don't forget to compensate for what you put in. At this point, we're going to rewrite that PST as a binomial squared class. X plus 4 squared, and then we're also going to simplify what comes after. Negative 2. If I were to graph this, it's now in the proper graphing form, it's going to be an ordinary parabola, but shifted down 2 and backward 4. Coming over here, I look just at the first two terms. What do I have to pull out, class? The 3. You cannot have a number before the x squared, so we pull it out. When we pull it out of the first two terms, what's left in the parentheses, Brandon?
X minus 1. Oh, then my x squared minus 2x.
X squared minus 2x. And then what do I do with the plus 6, class? You don't pull the 3 out of it. It's just a plus 6. You were only looking at the first two terms. Now, we've got to fill in the gap. What goes in the gap? Kendall?
+1.
A positive 1. But is it really a positive 1, Abby?
It's a politician.
It's a politician. It's really a
positive 3.
a positive 3. So to compensate for a positive 3, class, I've got to put negative 3. Michael's like, you're stealing my jokes. And so we're going to keep the 3, but this turns into the binomial squared, Maddie. X negative 1 squared. And then we're going to combine these together as well to get 3. 3 changes to my base parabola here. We are going to shift it, class, up 3 and forward 1, but we're also going to have to stretch it by a factor of 3, meaning over 1 up 3, over 1 up 9, over 1 up, we wouldn't actually graph that, but 15, right? You get the idea. Questions on this? Let's look real quick just at this. If you would get some graph paper out, I mentioned we'd be doing some graphing today, so we'll get some graph paper out. Let's graph this first parabola just to give us some practice here. Again, traditionally, we would have an x-axis and a y-axis, but when you graph, you'll use whatever axes are notated for you. Here it's x and f of x. Again, it all hinges on the vertex. Where does the vertex end up? Class? Good. Negative 4, negative 2, because you're going backward 4 and then downward 2. So here in the third quadrant, that's where my vertex will be. No flip, so I really do get to go up, and no stretch or compression. So I get to go over 1 up 1, over 1 up 3, over 1 up 5. And that's usually sufficient to get a really good graph, and that'll be the case here. Remember, the only thing we got to make sure we avoid is don't make it straight lined where it looks like a sharp pencil point, but a rounded curve. In just a moment, practice that. You will have, I believe, 1 of these on the exam. So not a lot, but did want to make sure we're good to go with graphing it. So practicing that again. Been a little while since we've done this. Had the computer help me out with some the other day, obviously. It's kind of cheating. You can't do that on the exam. One day when you're the math teacher, you can. Questions on this? Do number 35. You can use the same Cartesian plane when you're done with it, but I want you to do 35 now. f of x is a negative 2x squared, positive 4x, positive 5? Negative 5. We're going to convert that to the standard form and graph. How many pulled out a negative 2 here? Pulled out the negative 2. Good. Now be careful when you pull out the negative 2, when you're pulling it out of the positive 4x, did you also get a negative 2x in the middle? So the scary thing about negatives, you got to make sure you account for them here. So what goes in the gap here, Michael?
1.
A 1. But it's really got what value?
Negative 2.
Negative 2. How do I compensate for a negative 2?
You add 2 to the
A
side.
positive 2, good. So we've got our negative 2. What's the binomial squared going to be here? Genesis? There we go. And then we combine at the end, of course, we'll get a negative 3. All right, so there are actually 4 changes to our graph. Start with the shifts, because that's the easy stuff. Class, we're going to shift it down 3, but we're also going to shift forward 1. So our vertex is going to be at 1, negative 3. Instead of going up, we're going to flip it and go down, but we're going to accelerate down, right? We're going to go down quicker, amplitude or stretch of 2. So class, we're going to go over 1, down 2. Then if there's room on your Cartesian plane, over 1, down 6. And there should be, yeah, just enough room. All right, over 1, down 6. And get a nice smooth curve. A little harder when it's stretched out a little bit to keep the curve, but hopefully you did. How many had something like this for number 35? Something like this for 35. Questions on graphing parabolas? Questions on the quadratic functions? All right, well that concludes the planned review. Let me skim through the exam very quickly, make sure we're good to go here. Remind me again, what is domain? So which letter would that be? X, right? All the X values you plug in, and then the range would be f of X or Y values that you get out or obtain, right? Systems of equations, lots of systems of equations. Yesterday, I believe, let me check my notes from yesterday, we practiced with, I think we did, let me give you another one of these, some coordinate geometry practice. Distance formula, slope formula, midpoint formula, finding equations, all of that stuff. So let's suppose I gave you a point, and let's just call it A, and A has a value of 3, negative 2. And let's suppose we have another point M, and it's the point negative 1, 4. All right, and I want to find the length of line segment AM. I want to find the slope of line segment AM. I want to find the midpoint of line segment AM. And finally, I want the equation of AM at your seats. Why are we analyzing AM in an afternoon class? I don't know. Thank you, Abby. I needed that. It wasn't really a good joke, but you laughed anyway. Thank you. New favorite student. I feel like everything on the test has been reviewed pretty well, so. The trick is you doing it all in 50 minutes instead of a span of 2 days. But I won't keep interrupting and talking, so I'll just be quiet and let you work. At least that's the plan. Depends on if anyone starts singing next door. All right, questions on any of these four? You say, I'm still not quite sure how you did or what you did or what I did wrong. Any questions on length or distance, slope, rise over run, midpoint, or equation? Questions on any of those four things? All right, any last questions before the exam, which will be in our next lesson? Any questions? Got about 2 minutes if you have questions. Any last requests?
Is that the exam up there?
It is the exam up here.
Can we see it?
Tomorrow.
Can we throw it away?
No. I mean, you can, but then, 0 and... We'll see it next year, though. I mean, give you a second chance at perfect Algebra 2 test.
Oh, no, I think I'd rather take it.
Try to think positive. All right, any questions? Any legitimate questions? I did say any questions. I guess that's what I get. The girls are sitting there being wise and the guys being like, oh, I'm stupid, I'll talk. That was me too, so I'm not judging. All right, well, we will have the exam tomorrow in our next lesson. Have a wonderful rest of your day, and then when the bell rings, you'll be dismissed.